Hey class, welcome to the last section of chapter 7. It's going to be all about scale drawings and models, so a couple vocab words you're going to want to write down to start. First off, a scale drawing or a model is just a drawing or an object that has lengths that are proportional to the original object itself. So you guys know what models look like or what scale drawings look like. A map is a perfect example of a scale drawing. Models, if you ever had little tiny cars or little tiny dolls or animals, okay, those would be scale models of the actual objects themselves. And then a scale is a ratio. Remember, we said in the whole chapter so far, a ratio is just a fraction of a length of a model to the length of the original object. Now, sometimes we may not necessarily talk about specifically length, but as long as you know that a scale is a ratio of the model to the original, that's all you need to know. The first example I guess I want to go through, and then we'll talk about a couple other definitions. This example is just using a map, so I've got this one already up here for you. You don't have to draw this in, but you're going to have some similar to this on your homework, where you're going to have to look at a map. You may even have to have a ruler, so just be aware that you may have to have one handy. But this one says the scale on the map shown is 0.4 inches to 40 miles. So we didn't write it as a fraction. On maps, you usually see it written this way or with the colon in between. And they tell you find the actual distance from Nashville to Memphis if the distance on the map is roughly 1.5 inches. Now, here I tell you what the measurement is, but on your homework, you may have to measure it yourself. All right. So if you have trouble with a ruler, please let me know. So they are looking from Nashville to Memphis. So because we know the scale and we're looking for the actual distance, we just have to set up a proportion. So all I'm going to do is take my scale that they give us, so 0.4 inches over the 40 miles. And remember, we want to make sure we match things up. So on the top, I'm going to have inches. So we know it's going to be 1.5 inches. And we're looking for the number of miles. And then all we have to do is go ahead and cross multiply. So just like we've been doing this entire chapter. So we're going to go ahead and take 40 times 1.5. That gets us 60. And then 0.4x. And then, of course, we can just divide by 0.4 on both sides. Hopefully this part is pretty easy because we've done it the whole chapter. And we get that x is equal to 150 miles, approximately. All right, and that's it. So a couple problems like this on your homework shouldn't be too bad. Just make sure that you match up your units. So if you start with inches on the top, make sure you start with inches on the right, and so forth. Okay. Now, what is important and what can get a little tricky in this section is the difference between scale factors and scales. So scale factors, they're always written without units and they're always going to want to be reduced. So that might be 1 to 2 or 5 to 7 or 6/8, and then you'd have to reduce it. Okay, so they're always written without units. So no inches, no feet, no centimeters, nothing. And when we talk about these particular ratios, usually the model comes first. And that's important just to be consistent, so that way we know we're referring to the model first and then the actual object second. And you'll see why here in a little bit. And then scale factors, like I said, are different than scales. Scales can have units. All right, so a scale factor are just a ratio, a number, whereas scales are going to be like 4 inches to every 7 miles. All right, so those scales are going to have units, scale factors will not. Make sure you write that down. So let's try an example where we have to know the difference between the scales and the scale factors. So this example says you have a miniature replica of a 1923 checker cab, and it says the length of the model is 6.5 inches, so that's important. And it says the actual length of the car is 13 feet. So two numbers that we're going to use. So in part A, it says, what is the scale of the model? So remember, scale can have units. So I'm going to go ahead and write the information that we have as a ratio. So 6.5 inches over 13 feet. And then remember, we said in scales, we want to reduce it down as much as possible. So if I reduce, usually you want to have 1 to something if you can. So if I divide both sides or both top and bottom by 6.5, I get for every 1 inch, I am going to have 2 feet in my actual car. So what this means is every inch on your model represents 2 feet for the actual checker cab. And this would be my scale. Now in part B, this is where it gets a little bit different. When it says how many times as long as the car is the model, it's kind of worded a little weird. Basically, they're asking you how much larger or smaller is the model. So they're asking for the scale factor. So here, I put a little note underneath, kind of in small font. A scale factor of a model that's smaller than the original is going to be between 0 and 1. In other words, it's going to be a fraction. Whereas if the model is bigger than the original, so maybe you made something larger than the original, then you're going to have a scale factor that's larger than 1, which hopefully makes sense. You're going to multiply it by something instead of dividing it by something. So remember with scale factor we said that we don't want units. So this is where we have to pay attention to what our scale was, and if we have two different units that will not cancel, we have to make them cancel. So I'm going to go ahead and write my scale from part A, so 1 inch to 2 feet, and I want to make my units be able to go away. So what I need to do is multiply the top and bottom by things that will cancel out. So I know I'm going to be talking about in 1 foot, how many inches are there? Well, there's 12 inches. And the reason I did feet on top is because it will cancel out with the 2 feet on the bottom, and inches on the top left here will cancel with inches on the bottom right. And so now if I cancel out my units, so feet cancel, inches cancel, then I just have to multiply straight across. So when I multiply straight across, I get 1 over 24. So notice there are no more units, and what that means is that the model is 1/24th the size of the actual car. So it's much smaller, and notice it's a fraction, it's a decimal answer, so it's going to be between 0 and 1, which meant it was smaller. Okay, so there's our scale factor, and then part A was our scale. So if you have any questions about the difference between the two, make sure you ask me in class. Now this last example that we're going to go through is going to be one that will be very useful on your model project that you're going to do in class. So this example says Sonia is making a scale drawing of her room on an 8.5 by 11 inch sheet of paper, and the actual room she's drawing is 14 feet by 12 feet, and they need her to come up with a scale for her drawing and then determine what the dimensions of her drawing would be once she's ready to actually start creating it on her paper. So the biggest thing here is making sure you're coming up with an appropriate scale that would allow you to draw your image onto your paper and not make it too small or too big. Okay, so my suggestion when you do these types of problems, when you have to come up with your own scale, is to usually come up with and find the largest dimensions and then divide them. So you know your drawing has to fit on an 8.5 by 11 inch sheet of paper. Well, if you look at the dimensions of the room, you have 14 feet by 12 feet. So what I'm going to go ahead and do is divide the 14 feet, because that's the larger side, divided by the 11 inches. So when we do that, you're going to get a decimal, of course, but we get about 1.3. Okay, and then when I divide my smaller dimensions together, so I've got 12 feet divided by 8.5 inches. When I do that, I'm going to get 1.4, roughly. And sometimes you may need more decimals just to make it a little bit more accurate, but here it's okay to round in the nearest tenth. So if you look at this, what this is telling you is that for every inch on your paper, you're going to need something larger than either of these decimals. And obviously you want to pick a scale that's going to be really nice to work with. Okay, so you don't want to pick something like 1.275 because that's not a very easy scale to measure out. Instead, you want to pick something in maybe halves or whole numbers. But you don't want to go too big, because if you make your scale too large, your drawing is going to be really, really tiny and not use up the space that you need. So in this case, we could say that for every 1 inch on our paper, maybe we have a scale that's 1.5 feet. So for every inch on the paper, that represents 1.5 feet of the actual room. Now you could have done 1 inch equals 2 feet, okay? So you could use nice whole numbers if you want. Just know that the bigger your scale is, the smaller that your actual drawing is going to be when you create it. So you want your scale to be as close to your actual dimensions as you can, so that way you're using up the space on your paper as much as possible. All right, so then it says we've come up with an appropriate scale, so we did that, and then we have to determine the dimensions of the drawing. So using this scale that we've created, how big would our actual drawing be? Because we want to make sure it's going to fit on an 8.5 by 11 inch sheet of paper. So all you have to do is take the dimensions of the room, okay, so that 14 and the 12, and divide them by the number of feet that we want to represent. So I'm going to take 14 divided by 1.5, okay, and when we do that, we get 28 thirds inches, okay, or you could look at that as 9 1/3 inches. Same thing, just one's a improper fraction, one's a mixed number. And then we also want this to be 12 feet divided by our 1.5. Okay, so if we divide that out, we're going to get 8 inches. So would an 8-inch by 9.5-inch drawing fit on an 8.5 by 11? Well, 8 inches will definitely fit on 8.5, and 9 1/3 inches will definitely fit on 11 inches. So this would be perfect. So we'd say that it's going to be an 8-inch by 9 1/3 inch drawing, which definitely fits on our paper, which is good. So when you do this in class, and you have to come up with your scale, you want to make sure that when you actually figure out your drawing dimensions, that it's going to fit on the given size paper or poster board that you're going to be working with. All right, so I want you guys to go ahead and try this next example on your own. It says Gerard is making a scale model of the classroom, and he has an 11 by 17 inch piece of paper, and the classroom dimensions are 20 feet by 32 feet. So I want you to come up with an appropriate scale, and then I want you to calculate using your scale that you create what the dimensions of his drawing would be, and then go ahead and type that in. So if you have any questions on the scales, just let me know. Otherwise, when you're done with that problem, then you're good to go. Thanks for listening.